Welcome to our show today. Have you ever looked at objects and thought about how they move or what causes them to move? We shall be exploring the scientific principles behind that today. Think about a rocket. What makes it take off from the ground and push itself upwards into space? We shall soon find out. Before we start, let's talk about the scientific principles.
Force.
Amount of push or pull on an object.
Thrust.
Mechanical force that pushes an aircraft or a rocket through the air.
Pressure.
Amount of force exerted on an area.
Power.
The rate at which energy is converted or work is performed.
Newton's third law of motion.
This is a law that states for every action, there's an equal and opposite reaction.
Who was Newton?
Isaac Newton was a mathematician, an astronomer, and a physicist, and he came up with many laws in physics that we now use today.
That's good.
So what are some of the practical applications of Newton's third law of motion? We have skating, we have paddling on a canoe, we have basketball, so the ball bouncing up and down, we have a rocket, which we've talked about, taking off an aircraft, and we also have the trampoline. Shall we get on and demonstrate? So the action is the jumping up. Okay, as you're thrown up, you're pulled back down by the gravity, and there's an opposite reaction of bouncing back up again. And there we have it, Newton's third law of motion. Whee!
Let's have a balloon race.
All right, what do we need?
We need balloons.
Okay, so we have two different types of balloons. We'll have a long balloon, and we have a big fat balloon, and we have a medium balloon, right?
Yep.
Okay, so let's start by
Pumping up this one.
okay. There we go. So remember, as you're pumping the air into the balloon, you're increasing the gas particles in the balloon. So what happens is the gas particles, as they increase, they're colliding against each other. And as they collide against each other, they create more pressure. So it means that the pressure inside the balloon is much greater than the pressure outside. Okay? There you go. And that can also be demonstrated using this tin we have here of Sim Sim. So imagine the Sim Sim balls here are your gas particles. Okay? As you shake them here, you can see them hitting against each other. As you increase them, the more the collisions happening inside the jar increase, and that's exactly what was happening inside your balloon. You got that, Stephanie?
Yeah.
Okay, so now let me blow up my balloon. I'll start with this smaller one here. Wow, this is hard, Steffi. All right, I'm ready. Are you?
Not quite yet.
Okay.
I'm ready now.
Okay. So let's go. So what we have done is that we have set up our race using two chairs, and we have attached a string to the edge of each of the chairs. Now in that string, we have put a bit of plastic straw right here, and that is what will help the balloon to move smoothly along the string. All right? And right after this, we'll be explaining the science behind the balloon moving forward. Are you ready, Steffi?
Yep.
Okay, I think you need to turn your balloon the other way. Yes, there you go. Okay, and here we have some sellotape. So everyone is going to attach their balloon to the bit of straw. Okay, and don't release yet. There you go. Hold on.
Only one.
Only one. Okay, and you've got to bring your straw right to the end so that we have a fair start, right, Steffi?
Yes.
Okay. All right, so on your mark, get set, go!
No!
Yay! Okay, so we see in that race the blue balloon won against the pink balloon. Ideally, what should happen is that this balloon that is longer should be able to go faster than this one. But as you know, with science, things fail. Keep trying until you get it right. So the other way we're going to try and do it is if we use a bigger balloon, which we know holds a bigger volume of air against the blue balloon. So Steffi, blow up.
I want a big one.
Okay, go ahead. Have that big one. I think that's enough, Stephanie. Let's try it with that. Yours is way bigger than mine.
Yes, I win.
Okay, so come here on this side. You're going to try and... Okay, make sure it doesn't touch the ground.
Oh, finally. Mine's gonna win for sure.
Okay, let's try it. No, it has to come right at the front here. Closer to the front. Yes. Otherwise, you will not win.
You're not letting out air, of yours.
Yeah, there. So Steffi believes that her balloon is going to win, and I believe that mine's going to win. All right, so ready? Let's go to the starting line. Ready, steady, go! Yay!
She lost. I won. It was a tie.
So we can see because her balloon, the red balloon, still had a lot of air in it. If the course was longer, it would have definitely have gone much further. Okay? So well done. So what pushes a balloon that way? Do you know the science behind what pushes a balloon that way?
That sounds complicated.
Okay, so let me explain it. So as we blow the balloon and put air into it, remember there are gas particles, and as you increase the gas particles, the air pressure builds up, so it's greater inside the balloon than outside the balloon. So when you release the opening, okay, and the air rushes out, the air that's coming out is pushing against the air that's outside. And the air that's outside is also pushing against the air that's inside. And that opposing force is what is called thrust. And that is what pushes the balloon forward. You get it?
Yes.
Great. All right, so there's different ways you can vary this experiment as we did. You can have different sizes of balloons. So you can have the small ones, you can have the bigger ones, you can have the longer ones. So whichever size of balloon. So vary that to see which one goes farther and which one goes fastest. Okay?
Okay.
The other thing you can do is then increase the length of your string to see how much farther they can go.
Have you had the balloon joke?
No, I haven't. What is a balloon joke?
What do you call a balloon rush hour?
I don't know.
Chaos.
Chaos. Well done, Steffi. Thank you for watching us today. Please remember to like our Facebook page, Zazi Show KE. Follow us on Instagram on Zazi_show. And
don't forget to like, subscribe, and leave a comment below. Bye.
Bye. Let's do our race again.